Okay, hello and welcome to today's exercises where we will be talking about classes. So classes is a big and an interesting subject in Python, and I can see there's quite a lot of introduction text here, so I think it makes sense that I talk a little bit about that to get you started with the exercise. So first of all, what are classes about? Classes are fundamentally about organizing your code. You have certain data and certain function that tends to go together. For instance, in a video game, you might have a video game character with certain properties, and then you have functions that maybe it renders the video game character on the screen, or maybe it takes some, let the video game character take an action like jumping or shooting a gun or something like that. And you want to bundle all of that together in one logical place in order to make your program more understandable. And classes are the way we do that. In addition to that, classes are used very extensively throughout Python and all the big modules that you will interact with in Python like Matplotlib, NumPy, SymPy, and you'll see mathematics and PyTorch, which is used extensively in machine learning. So classes are very important subject if you want to understand Python in a little more depth. That means that classes can sort of have an air of being very confusing, like we can see that these examples are relatively big, but they're really not. And I think when we break these examples down, they turn out not to be so complex actually. So I think that's what I'll just do, and I think I'll just invent a parallel example to what we have here in the introduction, just to make it a little bit more varied. So let me create a file and let me call it classy.py, and this is just so I have a place to store my code. So I'm going to start by writing a class and working with it here. So the way you write a class is you use the class keyword, and then you need to give it a name, just like we need to give functions a name. And in this case, I'm going to write one that's called basic dog. Let's call it that. Then you need, and I know that I'm just doing things with by muscle memory, but you need to terminate the line with a colon. There are no parentheses here, which we would have in a function, but we just terminate it with a colon instead. Then we need to put some code here, and maybe I put a variable called name, and I'm just going to write some code here. So I assign the variable name to the value unnamed dog, and maybe let's just keep it at that to make everything as simple as they possibly can be. Okay, so this is how we define a class. How do we actually use that for anything useful? Well, in order to illustrate that, let me just put in a blank line. This is just a line with a for, so we can start the debug and explore this class a little bit. So just go into the debug console, and maybe the most natural thing to do is just to see what happens if I if I type basic dog in the console and see what that resolves to. So we see that Python tells me that basic dog is defined. Well, I've done that up here. And actually it's defined as a class with this name. You can ignore what it says here. That's not important for you. So this is a class, and it has this name internally. You can compare that to, yeah, let's just stick with that. Okay, so how do I actually use it? Well, this is where you enter the first place where you need to really learn something new, because we distinguish between classes and objects in Python. A class is just what I define here. A class is the general concept of a dog. It's sort of an abstract quantity. Like if I say dog, I'm referring to all sorts of dogs, right? Like we know that, you know, it could be this dog or it could be that dog. Objects, on the other hand, refer to specific dogs, right? So maybe a general dog has certain properties, like it barks, it has a certain weight, it has a name, and it has an age, and so on. But a specific dog has a specific weight. It it barks in a certain way, it has a certain age and a certain name and so on. We make the same distinction here. So let me try to make an object. The way we make an object is that let's write Lassie, and then I just write basic dog. I basically call my class as a function, and that is going to create an object. So let me try to do that. Now we can see if I type out Lassie here in the terminal, Python will say that Lassie is a basic dog object. What really just happens here is that when I call the class like this, like a function, it's not a function, but I call it like a function, it creates an object, and that object is assigned to the variable called Lassie. And I can of course create multiple objects. So let's make another one called Pluto. And I just repeat the line. And now we see that Pluto is also an object. Okay, so what does that actually mean, of course? Well, what about this name variable? What I can actually do, and this is where you just need to know something specific, is that I can do lassie.name, and it's going to give me access to the variable here. So when I have an object, remember that Lassie is an object, and I type name, it allows me to access things that I defined in the class. And that's exactly like the relationship that I tried to describe before. We have an abstract dog, it has a name, and then we inside the objects, then the objects will also have a name, and they'll have this default value that I set up here. I can change that value, so I can say that name should be equal to Lassie, and now we see that when I type lassie.name, it's Lassie. What about Pluto? What is Pluto's name? That is really the big question. Well, it's still unnamed dog. So what happens here when I create an object is that the objects are, they have the same variables as I define up here, but the particular instance it's called of an object, they have like their own version of the variable that can be changed independently. So if I, for instance, type Pluto.name equals Pluto, then Lassie's name did not change, but Pluto's name changed. They are like completely separate things, and I can define separate properties in them. By the way, I can also give Pluto an age. Let's give him an owner. Let's do that. And now we see that Pluto's name is whatever it was before, but now there's a new variable inside Pluto called Mickey Mouse. So I can define variables inside the objects both by defining them in the class like this, but I can also actually just define them on the fly if I choose to do that. And we see that doing this to Pluto, it does not change Lassie. And in fact, if I try to access owner here, Python is going to complain and saying that this basic dog doesn't have the attribute owner, right? Because I didn't give it to Lassie. Okay, so this is one way we can use a class. We can of course also combine this idea of classes with functions. So I just try to type in some of the code that I did before. Let's say lassie.name is Lassie, and Pluto's name is Pluto like this. Okay. Now let's try to write a function that uses the name attribute. And I'll just write a function called say the name. And we give it an input argument, and I'll explain what it does in a second. And then it just prints out some things. So it prints out the name is, and then prints out dog.name. Okay. So if I call this function with Lassie, what happens? Well, let's just imagine that the function is just a regular function, so we don't even have to imagine that. What will happen is that I call it with this variable, so this variable is going to be passed into the function when I call it, and that means that dog is going to be actually equal to Lassie. And then it calls the second line, the name is, and then it accesses dog.name. Well, Lassie has a name attribute, so in fact this will be replaced by Lassie. So let me check that by stopping the debugger and just running the code as usual, and we can see that it says the name is Lassie. And of course, if I call the function again and I give it Pluto, it's going to say Lassie and then it's going to say Pluto, and that's because first I call the function with the Lassie object and then it says dog.name, and that's going to be this variable that I access. And then when I call it with Pluto, dog is now Pluto, and then when I type dog.name, it's going to access this variable and give me Pluto. So that's how you can write a function that uses a class. But actually we can do something a little more convenient. So let me just type some slightly mysterious code, and then I'll explain what it does after I finish typing it. Let's call it say the name better. So I just define a function inside the class, and that function I'm actually going to just reuse what it does here. So I'm going to put in a little bit of a different print message because I want to be able to distinguish the two for your sake. But otherwise this function is equivalent to what I have down here. It's just indented, so it sort of lives inside the basic dog class. Okay, now let's try to return to this example here. First of all, if I just run the file as I defined it here, it's going to do exactly what I did before. Right? At no point do I touch this function that's defined in here, so it just does whatever I did before. However, I can actually call this function, and this is where object-oriented programming begins to do something a little bit different than what we've seen before. So let me simplify the example and just have Lassie, and then the way I access this function is similar to how I access name. I just use the period. Then I can say Lassie.say the name better. So now I have access to the function, and then you would maybe imagine that I needed to pass in, like I needed to do something similar to what I have here down here, like I needed to pass in Lassie as argument, but actually I don't need to do that, and I'll explain why in a second. Let's just confirm what happens when I run this code. It says second attempt, so it has called this function. The name is Lassie. So how did that work? Well, what actually happens here is that when I run the code, it defines the class. We define a function, but that function is going to be completely ignored. Then it creates an object corresponding to this class, that basic dog, so that we call that in the variable, we store that in the variable called Lassie. We change the name attribute on the object, say its name is Lassie, so now this name inside the object is Lassie. Then we access the function, then we call the function. Behind the scene, Python will take this object and just plunk in as the first argument. So it's like equivalent. It's equivalent to doing this. But this happens behind the scene. It just takes Lassie and plunks it in here. And then it calls the function as usual. So now dog will actually be equal to this Lassie object. And then when it accesses, it says dog.name, it accesses this attribute because dog and Lassie are the same thing. And that is how it works. Okay, so let me try to elaborate a little bit more on this example, because this is one of the key things to understand if you want to understand object-oriented programming. So let's say that I want to be able to repeat this message a couple of times. So then maybe I'll give it also a times variable that's an integer, and then maybe I'll have a for loop for e in range times. This is how we make a for loop that iterates as many times as this variable as many times as this variable is. Maybe if this variable is 2, it will repeat it 2 times, and then we just output this message 2 times. So now I need to give this a value. How do I do that? And I'd actually just give it a value like this. Behind the scene, what this function will do is this. It'll observe that I have a Lassie object, and that will mean that I have access to the variables I define up in the basic doc class. No, it's not a Lassie object, sorry. It's an object in a variable called Lassie, but the object is of class basic doc. So I have access to all the things that I define up here. Specifically, I have access to this method, and then when I call the method, it takes this object, plonks it in as the first argument, so effectively I call the name, so we say the name better probably, as Lassie, 2. And that means doc will be equal to Lassie, and times will be equal to 2, so this message will be repeated 2 times, and that is exactly what happens. And I can elaborate on that as much as I want, so let's say we want to include a greeting, and the greeting could be like good, and then we could say the name is Lassie, it is greeting, like this, and now when I call the function, this is plugged in as the first input argument, and effectively I end up calling the function as this. And then when I run the code, we see we included the greeting. So this is how it works when we include functions inside classes. Now there is a last thing that's important to do here. Let's say we also want to give it an age, and let's say it starts out as being -1, and let's just try to explore what that actually means. Maybe you can predict it with what we've seen so far, but I think it's still worth covering. So now that means that when I type lassie.age, it'll have this default value that I set up here. And I can change it. I can say lassie.age is 3 years, and then I can type lassie.age and it's 3. And then I could also extend the example a little bit, so I can set if the age is, and then self.age. And now we see that if I remember to change the age here to 3, and I call this function, oops, what happened here? Sorry, I called it self. I should have said doc. I gave the variable the wrong name, and I did that for a reason that we'll get to in a second. Now we see that it can access the doc's age. I just typed self instead of doc by mistake. Okay, so this is how we can include more variables. But now we get to something a little bit inconvenient, because it might be the case that all docs have a name and all docs have an age, right? So when I want to define Pluto down here and say that Pluto is 8 years, right? We can see that this is the kind of stuff that easily give rise to errors when you program, right? Because you need to remember that it has to be called age and it has to be called name. And if you get one of these wrongs, like you're going to have a bug in your code, right? Like let's say you age, I spell it a little bit wrong, so now I spell it like age. And then if I try to call this greeting method on Pluto, and I'll just call it like this one and clumsy, well, we see that, oops, I called it for Lassie, I should call it for Pluto. Well, we see that it's -1 here. Why is that? Well, it's because even though Pluto has a age variable that's 8, this one has not been changed, and that means that I print out 1 here, and that's not intentional. Like, that's not my intention. So this kind of code is a little bit dangerous, maybe. Wouldn't it be nice if we had some way of always demanding that we specify a name and an age when we create a new doc? And wouldn't it be nice if we could basically collapse these 3 lines into one single line? Well, there is a way of doing that. So I can write a function here called init. This is just a special name, and I'm just using 2 underscores here. Just roll with it. It has to be called init, otherwise it won't work. And I just give it a first input argument called dog, and then the second input argument will be called name, and the third will be called age. Then if I say dog.name equals name and dog.age equals age, we made a new dog called name. It is 8 years old. Well, what did I just do here? I created a function. It has a funny name. It takes a first input argument dog, same as this. Then it takes a second input argument name, a little bit equivalent to what I have here, and then it takes an age, a little bit equivalent to what I have here. Then it stores these variables on the dog object, and then it prints out a little bit of a greeting. Well, what I can do now is that I can create a Pluto, and then I can say Pluto.init, right? I can do that. And then I could potentially give it these variables. Let me, instead of calling it this funny thing, let me just call it init like this. So I could call it init. And then if I gave it Pluto and 8 years, then what would happen is, of course, I would just call this method. The first variable would be kind of regretting that I have all of this code. Let me remove it and just push it to the end of the file so we can see everything in one screenshot. Now what will happen is that when I call this init function, dog will be equal to this Pluto object, and then basically I update the name variable in the dog in Pluto and put it equal to Pluto, and I update the age variable and set it equal to 8, and maybe I don't want it to be a string, and then it calls this line. So when I run this, let me remove all of this code as well, like this. So when I call this file, it says invalid syntax, and that's because I'm in interpreter. Now it says we made a new dog called Pluto. It is 8 years old. Wouldn't it be nice if I could simplify this even further? Like, wouldn't it be nice if I could just not have to remember that it should be called init? There is a way. If I call it init like this, and I call them, create the object like this, it's going to be as if I call this method with these input variables. It's a little bit easier to see what happens rather than explain it, but when I run this code, we can see that implicitly this specially named function is going to be called, and this message is going to be printed out. And now when I created Pluto like this, I can still call my other method, and let's say we repeat 2 times, and our greeting is you are a good object. Then we can see that we first call the init method, and then we call this function, and it knows that the name attribute has been set to Pluto, because that's what we did when we called the init method, and then we get the name correct, and then we just repeat 2 times with this greeting at the end, and we get this output here. So it's worth sort of studying how this example works, because it encapsulates all you need to know about classes in this week, and actually for the most part, I think also what you're going to see next week. Okay, so one last example. Let's say we do the Lassie example. Now we can just do it like this. Lassie, and Lassie was 3 years old, and we repeat 2 times, and the greeting is good. And we see now that this, oops, it shouldn't be called Pluto, it should be called Lassie for convenience. I mean, because otherwise we just override the other variable. But now we have like 2 objects, 2 different objects. They have different names, and they are all set correctly because we implicitly call the initializer like this. The very last thing is that although I called the first argument dog, it is much more a convention to call itself. There's nothing really special about calling itself. As you saw, the example worked when I called it dog, but it's just become so standard in Python that everyone does it, and that was actually why I misspelled it here. So from now on, we are going to call the first input argument self to signify that it's special, and it's special in the sense that when I call the method on the object itself is always going to be plugged in here at the first input argument, so self will always refer to the object itself, and therefore it has this name. Okay, I think I've spoken for maybe far too long time here. I hope this was a little bit of a help, and otherwise we'll encounter these constructions many times in today's exercise, and I think I'll repeat a lot of what I said here when we see that. So good luck with the exercises.